Before we get into the representation of graph, we need to know what graph is. So what are graphs? Graph is a set of vertices and its edges, and this is represented by G is equal to set of V and E. What is a vertex? Vertex is a special kind of point that describes the corners or intersection of geometric shapes. For example, A, B, C, these three are points in free space. What is an edge? Edge is a line segment that connects two adjacent vertices. Now let's talk about the 3 points that we talked about earlier, A, B and C. The line between A and B and between A and C are the edges. A graph can be represented as an edge list, adjacency matrix, incidence matrix and adjacency list. What is the edge list? Here is the definition of the edge list. Now let's consider the shown graph. Now this graph, it has vertices mentioned A, B, C, D, E and edges W, X, Y, Z, M and N. Let G be the name of our array. We have edge W for vertex A and B. So we throw the edge A, B into the array. Similarly, we have edge Y that defines the relationship between A and C. We put that in there too. We do this for all the edges. Our next method of representing a graph is adjacency matrix. Here is the definition. Now once again, let's consider the same graph that we used earlier. We need to draw a 5 into 5 matrix. We will name the columns and rows by the vertices. And let us name this matrix as G. Since there is no loop from vertex A to vertex A, the row A and column A in the matrix will be 0. Similarly, since there is an edge between vertex A and vertex B, the row A and the column B in the matrix will be 1. Likewise, for the edge Y between vertex A and C, we will mark the row A and column C with 1. Likewise, we need to fill in all the blocks of our matrix G. Now in our matrix, if we add up each row or each column, the sum that we get will define the degree of a vertex. Okay, now what do you mean by degree of a vertex? Degree of a vertex is the number of edges that a vertex has. When we look into a graph, the vertex C has 4 degrees. That is X edge from B to C, Y from A to C, edge M from E to C, and edge N from C to D. In a similar way, when you look into our matrix, if you add up all the elements of row C, we get 4. That's the number of degree. And also when we add up all the columns once, we get a sum of 4. Likewise, we do that for all our elements in a matrix. The next method of representing a graph is called adjacency matrix. Now let's consider the same graph that we've been using earlier. By definition, we need to build a 6 into 5 matrix, and let's name this matrix G. Now let's label the columns of our matrix with the vertices and the rows that of edges. In our matrix, since the vertex A as a edge W, we will mark the column A and the row W of our matrix G as 1. In the next blocks, we see that the edge X is not shared by A, hence we mark the column A and row X with 0. In the same manner, we see that vertex A as the edge Y, hence we mark the column A and the row Y in a matrix as 1. Correspondingly, we'll fill up all the blocks of our matrix. Once again, we see that if you add up all the ones in a row, you'll get a number of vertices of an edge, and if you add up all the columns, you will get the number of degree of a vertex. The next method is adjacency list. It's basically a combination of an edge list and adjacency matrix. Once again, consider the graph, and what you're going to do in a adjacency list is that we take every vertex and we will see the vertex incident to that vertex. For example, we see that for the vertex A, B, C and E are incident. Likewise, we compute the adjacency list to the rest of our vertices.